Section 4.2, Logarithmic Functions. In the last section, we talked about exponentials, and one of the points I made was that the graph, the exponential function was smooth and continuous, and it had an inverse that was also a function. That's really important because we use inverses all the time to solve various equations. If you have a square on something, you can use a square root. They undo each other. They're inverses. If you add something, then you can subtract something. Those are, to undo it, those are inverse operations. So in order to solve things that have exponentials in them, we're going to be using this inverse to get those solved. The inverse is called the logarithm, and the relationship between the two is if you have x greater than 0 and b greater than 0, but b is not equal to 1, then y is equal to log base b of x is equivalent to b to the y equal to x. So here we have something in exponential form, and here we have something in logarithmic form. Okay? So the function f of x is equal to log base b of x is called the logarithmic function with base b. Okay? Now obviously that b is called the base, but what goes right here where that x is, this is called the argument of the logarithm. And the argument, this part that's right here, always has to be greater than 0. This means we have to be worried about our domain. I could not take log base 2 of -3. It doesn't matter anything else about here. I can't have a negative number in here, and I will get an error message if I should do that. So we've just added another thing that in this course we have to be worried about when it comes to domain. We are not allowed to divide by 0. We are not allowed to take an even root of a negative number, and now we are not allowed to take a log of a negative number. Okay. So for these first few problems, all they want us to do is we're given something in logarithmic form, and they want to switch it to exponential form. Okay? So if you compare here, what happens? I have log base b of x. Log, this would be my base b. So if I'm just following the pattern, my b is a 2, and my x, what's in the x position? 64. Okay, and then y is whatever's right here. So my y value, if I'm comparing this, the y value would be 6. Let me rearrange this so it might be a little bit easier for you to see. 6 is equal to log base 2 of 64. And I wrote it this way because that's the order it's written in up here. If you're just pattern matching, your y is a 6, your b is 2, and your x is 64. So if I switch it to this form, I have b raised to the y power. So 2 raised to the 6th is equal to 64. Now that's strictly pattern matching and doing this. The way I learned this is more like an animation. Before I go on, I strongly recommend that you get in the habit of using a cursive L for your log, because if you use a straight line L, eventually you're going to read that as a 1 and make a big mistake. So a cursive L there, even though I know not everybody learns cursive anymore, a cursive L will help avoid a lot of mistakes. Okay, so the way I learned this is more like an animation. I imagined you take this value, whatever is right here, and it comes over here and it pushes that up. So this becomes 2, and it pushes the 6 up to the other side. It becomes an exponent, and then this value is right here, which is exactly what I got here. 64 is equal to 2 raised to the 6th. Learning it this way instead of going through and pattern matching every time usually is easier. And then we're not asked to simplify this. They're asking us to give it an exponential form. So this is exactly what they are looking for. Now let's do the same thing here. I have log base 5 of 125 is equal to y. If we think of this as an animation again, This 5 swoops over to here and pushes that y up. So I have 5 to the y power now is equal to, and the 125 comes directly down. So all we're being asked to do is to switch back and forth between the two forms right here. Now these definitely have uses later on. We're going to be using this type of thing a lot to solve some equations in a few sections. Okay, so now let's go the other way. We have something that is in exponential form, and they want us to switch it back to logarithmic form. Now you could memorize this again, but for me, what I just do is I think about this in reverse. I make a decent guess, and then I check to see if I can get back to here. So I am going to have log base something. Well, what is that base? That's always the part that swoops over and gives you and becomes the base for the exponent. Well, here's my base for my exponent. So I'm going to do log base 5. Okay. And then what gets pushed up? It's on the other side of the equal sign. So I'm going to have a -3 over here. So I'm going to end up, if I think about this in reverse, I'm going to have the 5 swooping over here and pushing up the 3 to be an exponent, -3. So what needs to go right here? 1 over 125. Now check it. Going backwards, the 5 would swoop over. I would have 5 to the -3 equal to the 1 over 125 would come directly down. So it is the same thing. Okay, let's do the cube root of 64 is equal to 4. Now there's something in here that is going to be critically important. You absolutely must remember that you can change a root into an exponent. Okay, remember that if you have b to the m over n, this is the same thing as the nth root of b to the m power. So right here, the 3 is the index, the 3 is the denominator of your exponent, and this is not raised to a visible power, so I'm just going to leave that as a 1. This is the same thing as 64 to the 1/3 power equal to 4. And now that I have an exponent here, now I will go to logarithmic form. This is going to be log base something, and that base is the thing that is at the bottom of your the part that has the exponent. So this is going to be log base 64, and the number that comes up here was on the other side of the equal sign, and so this is right here. Okay, log base 64 of 4 is 1/3. Okay, so now we're going to talk about a couple of properties from logarithms, and they look maybe a little bit scary when they're written in this form, but they're really easy to understand. It's easy to see where they came from. This first property, log base b of b is equal to 1. This is saying if you have a logarithm and you have the base and the argument, and the base and the argument are exactly the same, then your answer is 1. Well, let me show you where this comes from. If I take this and I switch it to exponential form, this b would come over and push up that 1. I would have b equal to b to the first power. You know this is true. B is equal to b to the first power. It's a tautology. It is absolutely true all of the time. So all they've done is taking something that's fairly obvious in exponential form and put it in logarithmic form. Number 2 is basically the same kind of idea. If I switch this to exponential form, I have 1 is equal to b to the 0 power. And anything to the 0 power is 1. So you take this, something that is a property we've had for a long time, and you switch this to exponential form, and you have this. So in other words, it doesn't matter what your base is here. If your argument is 1, your answer is 0. Okay, now look here. Number 3, log base b of b to the x power is x. Each of these was actually a special case of this one, okay? This is saying if your base of your logarithm and you have a base of an exponential in here, if these two are the same, then your answer is your exponent. Well, let's look at this first one real quick. This is understood b to the first power. I had a base and a base that were the same, and I got a 1 here and a 1 here. This one, I could have written x to the 0 power instead of that 1, and then I would have, well, no, b to the 0 power. And then you would have b, and your answer would be 0. But right here, this equals x. Let's just switch this over to exponential form again. This b swoops over here and becomes b to the x power. And what comes right here? B to the x power. Again, something that is obviously true when it's in exponential form, not quite so obvious when it's in logarithmic form. Okay, and then number 4 is basically the same. If I have a base here that is raised to log with the same base, then your answer is the argument of that log. Now what I'm going to do here is instead of going from logarithmic form to exponential form, here we technically have something in exponential form. So I'm going to go back to logarithmic form. Okay. Number 4. This b was obviously the log of a base b of something. So this will be log base b. Okay. And then this, if this was the base of a log, it came over and pushed up this. So log base b of x is on this side. So this b swooped over and picked this up as an exponent. And then what goes here must be x. So we took something that is obviously true when it's in logarithmic form and put it in exponential form. The reason I went through all of this is so that you see that these things don't come out of nowhere. If you understand where these come from, it makes it a little bit easier to remember these properties and to properly apply them.